All right. Hello, everyone, and welcome to our Friday webinar for Groundwater Awareness Week. Thank you for joining us today. My name is Sean Spencer, and I am an engineering geologist in the Sustainable Groundwater Management Office in DWR. This webinar is being recorded, and the recording will be made available online. We've also enabled closed captioning, so if you want to turn those on, you can look at the bottom toolbar and find your captioning options to opt in and use that feature. I'd like to thank everyone for joining earlier in the week. On Monday, we kicked off Groundwater Awareness Week with Director Namath, Deputy Director Goslin, and Chair Esquivel, giving us a large overview of how far we've come in the 10 years since the signing of SGMA. Stephen Springhorn and Heather Shannon provided us with great talks covering the state of groundwater basins in California, and DWR assistance such as planning, facilitation support services, and outreach and engagement tools. On Tuesday and Wednesday, we had outreach training for GSAs that was provided by Sarah Rubin from the Department of Conservation. And yesterday, Thursday, we had information about annual reporting, periodic evaluation, and amendments from Andrew Renshaw and Shane Edmonds. Today, we're looking ahead to the next decade of SGMA, discussing data collection and modeling. Thanks again for joining us today. To kick us off, I'd like to introduce our first speaker, Stephen Springhorn.
Thank you, Sean, and good afternoon, everyone. Thank you for joining today. So as Sean mentioned, I'm going to do a quick overview of the different California's Groundwater Bulletin 118 related activities and how those are connected, and then sort of tee things up for the other speakers that are on the webinar today. So next, please. And I am Stephen Springhorn, and I lead our technical assistance section in the Sustainable Groundwater Management Office. So what we wanted to really highlight is sort of taking a step back and looking at why are we doing these different data and tool developments and providing that information. And this started decades ago in the Department of Water Resources, and DWR really has a legacy of providing technical assistance and data and tools for water management and groundwater management. And some of these requirements go back to the 60s or before, where we're required to publish what's called Bulletin 118, California's Groundwater, characterize groundwater basins, as you'll hear more about today, and provide other forms of assistance. And throughout the decades from then till now, there's been a variety of different changes to the water code or requirements that have come in, such as the passage of the Sustainable Groundwater Management Act, or SGMA, which really was a huge shift and required a lot more information on groundwater in particular to be available. And so we've been really making some big changes and evolving how we provide those forms of assistance, and we'll be talking about those more today. And we've also seen changes in the climate and extreme shifts from dry to wet, and all of that requires a lot more information to inform local, regional, and statewide management. So next. And so one of the main foundations that that has been around for a long time and we're building off of and trying to get more aligned to these new requirements is California's Groundwater Bulletin 118. This is a comprehensive compendium of California's groundwater information, and it's published every 5 years. And we are well on our way to publishing Update 2025. And the California Groundwater is also connected to other documents like the California Water Plan, and supports those plans, and really to shape a current status of what groundwater is in the state, and also cast the vision or direction of where we need to keep things going to continue to make improvements. So next click. So really looking at California's groundwater, we're trying to, again, evolve the types of information that are available. So it's not just a big PDF document. That is important for archive purposes. But we also are trying to improve accessibility. And so these are the different informational resources available for California's Groundwater Bulletin 118. We have the update itself, which is typically hundreds of pages long and consists of highlights, statewide report, and it's currently in development, and with a targeted release of the draft in mid-2025 and a final released at the end of 2025. And for more information, you can go to that link there, and that'll be put in the chat. So the other thing we're trying to do that's relatively recent is we've created a semi-annual conditions report, groundwater conditions report, that's aligned and connected to California's groundwater. This gets information out every 6 months, which gives a little bit more frequency of data delivery and understanding of California's changing conditions. And then finally, to the right there, California's Groundwater Live. This was built back in 2020 and provides up to the day information on the latest conditions, groundwater levels, well infrastructure, and subsidence. And we'll be continuing to build on that as we go forward. So next slide, please. So now we're going to sort of show how the Cal Groundwater suite of activities connect with some of the other things you'll hear about today in more detail. Next click, please. So we have a long history, just like providing technical assistance. One form of that has been basin characterization, groundwater basin characterization. And this is really where the analysis, further understanding of California's groundwater basins has happened, and a partnership with local districts and agencies along with the state to do that. And that started back in the 60s and 70s. DWR was very active in that role, but there was a long pause because of resource challenges. But with the statewide AEM surveys and continued basin characterization that you'll hear more about today, we're really reactivating that. It's really exciting. And so that feeds into a lot of what you'll hear about from our colleagues today. And then also, next click, please, into the data collection. And so all of that, what we're doing with basin characterization that feeds into California's Groundwater Bulletin 118 is founded by important data that's collected, maintained, and made available. So really improving access, and we're doing a lot more data collection and providing access than ever before with new funding that we have going into the future. And last click, please. And we want to get that information out through various channels, public, with Cal Groundwater Live and Bulletin 118, the Sigma data viewer, 2 and 3D data viewers, and open data to inform local management. And so with that, I'll turn it over to Catherine Dulubac to go over basin characterization. Thank you.
Hello, everyone. Thank you, Stephen. Let's see. So hello, everyone. Catherine Dulubac. I am a senior engineering geologist in the Sustainable Groundwater Management Office, and I'm also the project manager for DWR's statewide airborne electromagnetic surveys and our recently launched basin characterization program. So I'm happy to be here today to provide you all with more information about what we'll be working on in the basin characterization program. Stephen hinted at it, but I'm going to give you more details about the data that we're going to collect and the analyses we're going to perform and the tentative timeline for when you can expect these products to come out. But I want to first, highlight our statewide airborne electromagnetic surveys. I'm not going to go through the details in this slide because Stephen did present on this on Monday. But we did complete the data collection portion of these surveys late last year. And if you're interested in accessing any of this rich data set, downloading the data, or viewing any of these data sets on one of our 2D or 3D data viewers, I would encourage you to go to the CNRA Open Data Portal webpage, and the website address is there. And I just wanted to highlight the statewide AEM surveys because, as Stephen mentioned, we are building upon the completion and the success of these surveys to roll into the launch of our basin characterization program, where really this program is more of the second phase of using innovative technology and innovative approaches to better characterize and understand our groundwater basins. So there are 3 main tiers of work that we'll be doing in this program that are shown here. The first is to continue to collect, compile, and digitize data. The data that we're going to be collecting is going to be specific, and compiling and digitizing will be specific to addressing Sigma, recharge, and groundwater related applications. So I have a list here of those, but they include things like defining primary aquifers, extent of clays, potential recharge sites, and so on. The next main pillar we have is developing texture and hydrogeologic conceptual models. And in order to do that, we'll be creating tools that can perform an integrated analysis of all the subsurface data that we collect, and then put out a texture and hydrogeologic conceptual model. And this is shown here as a loop because these will be state stewarded models. So as we continue to collect more data, compile more data, digitize more data, we'll run it through the tool and put out an enhanced version of that texture or hydrogeologic conceptual model. Then all of the data and everything we do will be archived in California's groundwater, which Stephen already highlighted. And of course, making sure that all of the data that we collect is made accessible, not only to be downloaded, but also acceptable through visualization platforms. So we've really been focusing on developing platforms that allow the public to access all of the data that we collect and visualize it on an online platform. And we know we're not the only ones that exist in the spacing and characterization space in California. There's been a lot of work that's been happening by locals and other state and federal agencies. So our plan here is to build on this community of practice that already exists. So coordinating closely with local, state, and federal agencies, non-governmental organizations, academia and the private sector, and in order to do that, create a basin characterization work group. So I could go into lots of detail at any single one of these topics, but I'm just going to focus in now on the collection of additional data. So we're going to be collecting additional data through a series of pilot studies, where the goal of these pilot studies is going to be to explore methods and techniques that address Sigma-related initiatives and to create guidance for both state and local groundwater managers to use, right? So we have the Sigma initiatives listed here that we showed on the previous slide. And now I'm also showing the different types of data that we can collect now under basin characterization. So we can go out, we can continue to collect airborne geophysical data. We can collect data, geophysical data from mobile systems that are towed behind an all-terrain vehicle or towed behind a boat, or advanced geophysical logging, or any of the traditional methods that we've used in the past to characterize sites. We have all of those available to us. And so the first three pilot studies I'm showing here, the first one will be focused on groundwater recharge. We'll then have another focus on interconnected surface waters, and then domestic wells and subsidence. And these are just three I'm showing, but there will be more as we move forward and advance through the program. And so a lot of data that we're going to collect, and we're developing these tools to analyze the data. And so I just wanted to highlight a few of the applications of how you can use these data sets that were coming out. So of course I mentioned the texture model, which is a model that describes the percent coarseness of the material in beneath our feet in the subsurface. So materials that are have a higher percent coarse are materials where water flows or there's larger pore space. The materials that have a lower percent coarse are finer materials like silts and clays. And we can use our texture model and along with other information to create a hydrogeologic conceptual model. So this is now where we are understanding the hydrogeologic facies, right? So the primary aquifers and defining the clay layers and other properties of interest. And both of these can then go into creating aquifer parameters that could go into a groundwater flow model. And Craig is going to talk more about groundwater flow models in a little bit here. We can also use these types of data sets to help us define potential recharge locations where we can get water, for example, in the shallow subsurface or into a deeper aquifer. So this is showing a map, this first one, that's the really colorful one, where we're showing the shallow subsurface average to the top 50 feet of the percent coarse material. And so these areas of reds and oranges have a high percent coarse. So we can have a good confidence that in that top 50 feet, those are coarse grain materials, and we could get water back into the ground quickly. We can also use this data now that we can see continuously in a regional space. We can better understand how some of these deeper aquifers could connect to the surface, and it can help us identify areas to get water, to put water to get it back into the ground quickly into a deeper aquifer. We can also use this data to define high salinity zones or base of fresh water, things like that. And then finally, for other groundwater management applications like siting wells, and Tad's going to talk more about wells, so I'll leave that to him. Okay, so lots of data and analyses that I talked about are going to come out. So here's a tentative timeline for when you could expect this type of information. So the Basin Characterization Program will be an ongoing program, and I'm just showing you here a 3-year snippet of what you can expect. So in late 2023, we finished the statewide surveys. We then transitioned right into kicking off the Basin Characterization Program. We have the Pilot Study 1 already underway, and we hope to kick off Pilot Study 2 and 3 later this year. And we'll, of course, continue our technical engagement that we've that has already been underway. We hope to later this year also come out with a recharge suitability map and an aquifer connectivity map. So one map showing areas where you can get water quickly into the ground, and another one showing areas where we could connect to deeper aquifer systems. And this has an arrow on it because this will be one of our stewarded products where we will come out with an initial product at this time, but then as we get more data, as we digitize more data, we'll be updating these into the future. We'll also be coming out with a Central Valley-wide texture model. So this would be a model that now not only includes digitized lithology logs, as has typically been done in the past, but now we'll integrate also the texture data that we got from our airborne electromagnetic surveys. So that will also be a stewarded model, as I mentioned before. We then hope to come out in 2025 with an advanced data viewer. So this will allow us to view the data that we're collecting and digitizing in a 3-dimensional space for the advanced user, but we'll also be building into Cal Groundwater Live, which Stephen mentioned, to allow a better understanding of what's happening in individual groundwater basins, so a snapshot of what those basins look like. Of course, we'll come out with California's Groundwater Bulletin 118 at the end of 2025. We'll also be making these analysis tools publicly available. So that tool that ingests all the information to create the texture model and the hydrogeologic conceptual model, we'll be making those publicly available so that locals can also run these tools as they would like to on their data sets for their basins. And then coming out with a Central Valley-wide hydrogeologic conceptual model. Again, that will be stewarded. And then later this year, we will be kicking off our basin characterization work group. So that will go on into the future. And if you're interested in joining our basin characterization work group, please send us an email at basincharacterization@water.ca.gov. If you're interested in learning more about any of the programs, basin characterization, or the statewide AEM surveys, those websites are there. And of course, please do have a look at the data, download it, and view it on our data visualization platforms. Okay, and that's it for me. So over to Tad.
All right, thank you, Catherine. Hi, everybody. My name is Tad Bettigrew, and I'm a Senior Engineering Geologist Specialist in SIGMO's Technical Assistance section. Today, I will be providing you all with a quick overview of DWR's new statewide groundwater monitoring initiative. First, I will provide some background information covering California's groundwater landscape. Then I'll dive into the purpose of the new statewide groundwater monitoring effort, which includes where we are now with a few groundwater monitoring networks and where we plan on going as this effort expands. Next slide, please. 40% of California is covered by a total of 515 groundwater basins, and 60% of California is covered by what we call non-basin areas. On the left side of the slide, in the 515 groundwater basins, over 20 million acre feet of groundwater has been pumped from these basins, and these basins account for over 90% of the groundwater pumped in California. Over 80% of California's population are in these basins, and over 7 million acres are irrigated by groundwater in these basins. It is very important that these groundwater basins are adequately monitored, since the majority of groundwater use occurs in these areas. These basins have been monitored by various efforts and programs such as CASGEM, SIGMA, local agencies and organizations, and voluntary data collectors over a long period of time. However, the majority of the state is considered non-basin areas. Any area outside of a defined groundwater basin is referred to as a non-basin area. Non-basin areas consist of impermeable granitic, metamorphic, volcanic, or sedimentary rocks where groundwater is found in fractures or other voids. On the right side of the slide, the figure shows defined basins in the tan color, but the gray areas to the left and right of the dashed line are the non-basin areas. Just because these are considered non-basin areas, groundwater is still present and being used. In fact, over 1 million acre feet of groundwater is pumped from non-basin areas. Nearly 7 million people live in non-basin areas, which includes the majority of disadvantaged communities, and the majority of domestic wells are in these non-basin areas. This slide shows that groundwater resources are very critical to the state, and it's very important that groundwater is monitored in groundwater basins as well as in non-basin areas. Next slide, please. This next map shows some of the wells that are distributed throughout the state. Each blue dot is a production well. So in this figure, there's approximately 280,000 domestic wells and approximately 60,000 agricultural wells. This map really highlights the areas of the most groundwater use, which is mainly in the groundwater basins, but also in these non-basin areas mentioned earlier, such as the coastal areas, in the foothills, and mountain areas. Next slide, please. As most of you know, the groundwater basins throughout the state have been prioritized. In this map, the yellow and orange basins are considered medium or high priority and are subject to SIGMA, but there are many more basins throughout the state that are considered low or very low. These are the green colored basins in the map, the lighter color green and the darker color green. Although medium and high priority basins are being monitored under SIGMA, we would like to expand and enhance groundwater monitoring in these basins, as well as in the low, very low, and non-basin areas throughout the state. Next slide, please. This slide represents the purpose and components of DWR's statewide groundwater monitoring initiative. Near the top, acting as a larger umbrella over the remaining components, you see the statewide groundwater monitoring effort. Directly beneath the first arrow, you see the purpose of the initiative, which is to maintain, enhance, and expand groundwater monitoring networks on a statewide scale. This includes standardizing data collection efforts and making the data available to everyone. The data collected under this initiative will inform local actions and planning efforts from individual homeowners, the general public, GSAs, and other local and state agencies. The overall goal is to monitor groundwater statewide better than we ever have before. So far, I have been generalizing when I say statewide groundwater monitoring, but now I'll take a little deeper dive into some of the specific monitoring networks I'm referring to. In the bottom left bucket, you see the Groundwater Elevation Monitoring Network. This groundwater monitoring network will build from CASGEM, which is DWR's California Statewide Groundwater Elevation Monitoring Program, which was initiated in 2009. In the middle, you see the Land Subsidence Monitoring Network bucket. As I'll share in a few minutes, DWR and other agencies have been collecting subsidence data statewide, which we plan on expanding and enhancing. Finally, on the right, you see the bucket for groundwater quality and other sustainability indicator monitoring networks, such as seawater intrusion and surface water depletion. I won't be discussing the monitoring networks in this last bucket today because initially with this new effort, we'll be focusing on groundwater elevation and land subsidence monitoring networks. As this new initiative takes shape, DWR will shift our focus towards these additional monitoring networks. Next slide, please. Now I'll discuss the current groundwater elevation monitoring network. On the left, you see a figure that contains approximately 10,000 blue dots. Each of these blue dots represents the location of a well that has been monitored in the last year or so. As you can see, there's a decent number of wells being monitored, but there's also pretty large portions of the state that are not being monitored. And one item that's hard to really be captured in this photo or this figure is that the current groundwater elevation monitoring network is not very representative of the depth of the wells, because in some areas there may be high number of wells being monitored, but all the wells might be in the deep aquifer zones, or all the wells might be in the shallower aquifer zones. Therefore, a simple dot map like this doesn't really capture the three-dimension aspect of an adequate groundwater elevation monitoring network. Additionally, there's a fourth dimension of groundwater elevation monitoring, which is represented on the figure to the right, which captures the frequency at which these wells are being monitored. This figure is from last spring. However, the frequency of data collection probably hasn't changed very much. This figure shows that only 44% of the wells monitored last spring were monitored and submitted within 30 days of data collection. Most of those measurements are considered low frequency, meaning only one data submittal during the spring timeframe, which is represented by the blue dots on the map. The orange dots represent the higher frequency data collection, such as multiple measurements collected in the spring, which is likely monthly to weekly data collection and submittal. The yellow dots represent very high frequency data collection and submittal, such as continuous data and/or data that is being telemetered. As I'll describe in the next slide, one of our goals is for this map to be totally covered with orange and yellow dots as we expand this effort. Next slide, please. Now I'll cover some of the information on how we plan on enhancing and expanding the groundwater elevation monitoring network. On the left is the same figure as the previous slide, showing wells that have been monitored over the last year. And our goal is to expand the number of wells being monitored, resulting in additional dots on this map, while also taking into consideration the depth that I mentioned previously. DWR is leading by example by installing dedicated monitoring wells through our technical support services program. A few additional examples on how we plan on expanding the groundwater elevation monitoring network is through further coordination with new partners such as community monitoring groups, individual well owners, non-governmental organizations, and other local, state, or federal agencies. Another major goal of this effort is to increase the data collection frequency. The example hydrograph on the right shows the importance of high frequency data collection to ensure that seasonal highs and lows are being captured. The majority of groundwater elevations collected statewide are on a semi-annual basis, or basically twice a year. In the figure on the right, the orange plot represents those two measurements per year of frequency. As you can see, the collecting data at this frequency really mischaracterizes the seasonal highs and lows. But the black plot with the black triangles represents monthly data collection frequency. As you can see, the monthly data collection frequency does a pretty good job at identifying and capturing the seasonal highs and lows. In an ideal world, continuous data collection is preferred, but and you can see that on the figure that the teal plot represents the continuous data collection. It might be hard to see at this scale. but it's very high frequency, and it captures some additional fluctuations in groundwater levels that the monthly data doesn't quite capture. And DWR has numerous monitoring wells that are collecting data at a continuous frequency, which we have been working on transitioning to telemetry as well. With this new statewide groundwater monitoring initiative, DWR has been, and we will continue transitioning from semi-annual to at least monthly data collection throughout the state. We're looking for all data collectors to also shoot for at least monthly data collection as well, and to submit the data in a timely manner, which will support our goal of enhancing the statewide groundwater elevation monitoring network. Next slide, please. So next, I'll discuss the current statewide land subsidence monitoring network. On the left of the side of the screen, you see the INSAR data that DWR makes available to the public. The image you see here is the total subsidence from 2015 to current. However, DWR also releases monthly INSAR data on a quarterly basis. In addition to this data being high frequency, the current INSAR data set covers 150 groundwater basins, which is mainly focusing on the high and medium priority basins that are subject to SGMA. On the right side of the screen, you see additional land subsidence monitoring networks that are spread out across the state. These additional networks consist of extensometers, benchmark surveys, and continuous GPS stations that are maintained by various organizations, including DWR, the USGS, and other regional subsidence networks managed by local agencies. The combination of INSAR data along with these additional land subsidence monitoring networks is fairly extensive. However, data gaps still exist, such as the location, depth, and also the data collection frequency, as I mentioned previously, with groundwater elevations. Next slide, please. Now on to DWR's plans to enhance and expand the land subsidence monitoring network. On the left, you see the annual time steps of that INSAR data that I was discussing. This is the data that DWR has processed and released since 2015. Currently, DWR is working on having historical data processed and expects to release INSAR data from 2003 to 2015 in the near future. In addition to having historical data processed, DWR will continue releasing the new INSAR data as it comes in on a quarterly basis, with potentially expanding coverage into some of the low and very low priority basins in the coming years. On the right side of the screen, you can see a map of some of the existing continuous GPS stations. DWR has begun installing and plans to continue installing continuous GPS stations throughout the state. The initial installations can be seen in the red dots. There's just kind of a few down the San Joaquin Valley, with some of our planned stations in the blue dots. Those are a little more dispersed at the moment. In this initial effort, we're planning on 20 or so stations to be installed within the next year or so. DWR will continue to release high frequency land subsidence data and look forward to working with others in the state to expand and enhance the statewide land subsidence monitoring network. Next slide, please. As I wrap up these slides, I just want to remind everyone that the purpose of this initiative really is to maintain the networks that we have, but also enhance and expand groundwater monitoring networks on a statewide scale. Again, this will include standardizing data collection efforts and making the data available to any and all, making it available to everyone. As previously mentioned, DWR will initially be focusing on the groundwater elevation monitoring network and land subsidence network, but we will begin focusing more on groundwater quality and other monitoring networks as this new effort takes shape. Again, DWR is leading by example by improving and expanding our data collection efforts, and we really encourage others in the state to support DWR in this effort. Again, the overall goal is to monitor groundwater statewide better than we ever have before. Next slide, please. This last slide contains some resources where you can find information and data related to what I shared today. We'll put some of these links in the chat for your convenience. And I'll also put my email in the chat if you have any questions on what you heard today. So thank you, and we look forward to working with you all as we navigate this new initiative. And I'll pass it over to Craig Altair to discuss groundwater modeling tools.
All right. Well, thank you, Tad, and welcome everyone to my 10-minute short course on groundwater modeling. Just kidding. I'm going to give a very quick overview today of some of our groundwater modeling tools and applications that the department offers, and it's going to be, just that, a quick overview. There's probably a lot more detail that you're going to want to know about, and apologies. I've got an email address at the end of my slide deck that you can email further questions to. I see there's some of my colleagues are on the call today listening in. Apologies if I skip over anything in my haste. So groundwater models are essentially computer programs that allow us to input data about our groundwater basins and groundwater and surface water conditions in those basins, and then simulate how groundwater and surface water flow and interact, both historically and projected into the future. So models can be useful tools because they allow us to look at scenarios and potential future conditions under a variety of different scenarios. They allow us to look at things like climate change, like the long-term impacts of implementing projects and management actions, and whether the benefits that we expect to see from those projects and actions are realized in the ways that we think they're going to be realized. So for example, models can help. They don't provide the final answer, but they can help us to understand questions like, when we recharge water, where does it go? How long does it take to get there? Shockingly, this is a 10-minute talk is not going to be an in-depth discussion of modeling fundamentals. But if you are curious about that kind of thing, I would encourage you to check out, among other resources, our Groundwater Modeling Best Management Practice, or BMP, document. And I have a link to that document on my final slide. And for that matter, all of the tools that I'll be talking about today are linked on that final slide if you'd like to take a look and get some information. So I'm going to spend the first part of my talk discussing the codes that we have available and some of the applications that we have available. And that will probably be useful for maybe those that have some knowledge of groundwater modeling generally, but hear terms like C2VSIM, SVSIM, and wonder what does that mean? What's the difference between those tools? And then I'll talk in a little bit of detail right at the end about one particular application that we're working on in our office, the Sustainable Groundwater Management Office, called C2VSIM Fine Grid, some of the kind of current and next activities that are coming up there. So next slide. Oh, actually, no, sorry, back slide. Back up one. There we go, thanks. So we'll start off with the IWFM and an IDC. So IWFM, the Integrated Water Flow Model, is the modeling code that the department makes available, provided and supported by my colleagues in the modeling support branch of the Bay Delta office. You can think of a modeling code as sort of the engine of your model. The code itself, in this case IWFM, doesn't know anything about local conditions, but it is the kind of container for the the equations and numerical methods that solve the groundwater flow equation, among other things. IWFM is comparable to some other modeling codes that you may have heard of, like the ModFlow family of codes that's provided by the USGS. And really, IWFM can be used by most basins in California for most conditions that we face in our state, short of maybe some coastal basins that have density dependent flow that they need to simulate with more advanced tools. But for the most part, IWFM can be used by most GSAs in the state. And I put another tool up here, the IWFM Demand Calculator, or IDC. It's a tool you can use either integrated into IWFM or on its own. And it's important because it allows us to calculate water demands both in urban and agricultural areas. And it can take information, for example, in agricultural areas on climate data, crop types, crop acreages, soil properties, and irrigation methods to calculate the crop demand. Why is that important, you might ask? Well, because we can use knowledge of the demand along with information on the types of water that are available from precipitation and surface water supplies. We can use that information, the supply and demand, to back into how much groundwater pumping is occurring. I'm sure most of us know that throughout our state, much of our pumping is unmetered. And so to effectively model the groundwater conditions, we need to be able to determine what that groundwater pumping is in unmetered areas. And IDC, coupled with IWFM, really allows us to do that well. Next slide. So moving from the code to the application. DWR hosts several applications, and I'll start with the coarsest of those applications right now, coarsest in resolution. And that is a model application that we call this C2V-SIM, which stands for California Central Valley Groundwater Surface Water Simulation Model. And we have two versions. The first that I'll discuss is shown in the pink on the right. It's the coarse grid version. The coarse grid version is actively maintained by, again, my colleagues in the modeling support branch of the Bay Delta office. And although it is still maintained and actively used today, it is kind of the closest thing you might think of to like the grandfather of the models that I'll talk about today. It has the closest direct lineage to some of the earlier modeling efforts that go back into the, at least the mid-1980s. And today, one of the main uses of C2V-SIM coarse grid is to support some of our Central Valley surface water operations and planning models like CalSIM 3. Next slide. In the years before Sigma was passed, we knew that groundwater managers needed, both at the state level and local groundwater managers needed a more finely resolved tool to look at groundwater conditions in the Central Valley. And so we developed a fine grid version of C2V-SIM. The fine grid model is shown there again on the right, and I'll have a subsequent slide that compares the resolution in a little bit more detail between all these modeling applications. The fine grid version is again supported by my group in the Sustainable Groundwater Management Office. Version 1.01 of that model was released in 2021, and it simulates historical conditions from water years 1974 to 2015. I should have mentioned that the C2V-SIM coarse grid model has a version that also simulates water years 1974 through 2015, but they also have some baseline versions that are available that allow you to look at a longer time frame from the 1920s, using historical hydrology from the 1920s through 2015. I'll talk a little bit later about some specific work that we're doing in the Sustainable Groundwater Management Office to update C2V-SIM fine grid in a moment, but if we could go to the next slide. I'll talk about the third and final application that DWR hosts, and that is a focused model of the Sacramento Valley area that we call the Sacramento Valley Groundwater Surface Water Simulation Model, or SVSIM. SVSIM was developed, it started development even before Sigma as well. It was released in 2022 as a final, or not a final version, but I guess a production version. There were some beta versions that came out before that. It also simulates water years 1974 to 2015, and it was developed to look specifically at groundwater surface water interactions in the Sacramento Valley. Next slide. So we talked about C2V-SIM, SVSIM, and if you're a groundwater manager wondering which version to use, of course you'll need to have the right geography. Being in the Central Valley, these models are focused. But if you're in the Central Valley, you may ask yourself, which version should I use? C2V-SIM, a flavor of that, or SVSIM? And a lot of it's going to come down to the resolution and how that matches up with the kinds of questions you want to answer. I mentioned the C2V-SIM coarse grid is the coarsest in resolution, with an average element size, and element is each of those polygons that are shown for example, in the coarse grid in the pink on the left. Average element size of around 9,000 acres. The C2V-SIM fine grid model has an average element size of around 400 acres, so much more finely resolved. And SVSIM has a resolution with an average element size of around 200 acres, and a lot of that refinement relative to the C2V-SIM fine grid model comes in the form of refinements along the streams. And so you can see, it's actually a little hard to see even the individual elements of SVSIM around the streams, which are those kind of darker colored black areas. because they're so small, down to sub-acre element size along some of the stream reaches. But that allows for somewhat better resolution to simulate groundwater surface water conditions. It's important to mention too that SVSIM has 9 layers versus the 4 layers that are used in CTVSIM coarse and fine grids, which are, all models are simplifications of reality, but those 4-layer models, are a relatively more simple representation of our aquifer structure than the 9 layers in SVSIM that allow more refined hydrologic parameters like hydraulic conductivity, but also better assignment of the vertical pumping intervals. So again, if you're a GSA wondering which to use, this may help. I encourage you to look at the documentation for more, and you can certainly reach out if you have questions. Next slide. So I just wanted to touch briefly on the main application that that our office works on, the CTVSIM fine grid model. CTVSIM fine grid was used by some GSAs developing their groundwater sustainability plans. Some used it more or less off the shelf. Some used it with the full model domain of the Central Valley that made some refinements for their local area. And some cut out portions of the model, and they would carry forward only the domain that was relevant to their basin and maybe some of the surrounding areas. But in any case, it was used by GSAs. So we want to keep that going, keep our updates going so that it remains a useful tool to the GSAs. So my team has been working diligently on the next version of CTVSIM. Internally, we've been calling it version 1.5. It could be released, a form of it could be released as soon as summer 2024. If it is released in summer 2024, it will essentially be a limited calibration version. We might call it a beta. And again, there has been some precedent for releasing beta versions of our models in the past. So it won't be a fully calibrated version, but it will go through water year 2021. And we'll continue to work to more fully calibrate it, as well as to continue to expand the features that are included in CTVSIM fine grid into summer 2025 and beyond. Next slide. So I've tabulated, and I definitely don't intend to read the words on these and then the next couple slides. I don't intend to read them verbatim, but they're there for your reference if you would like to take a look at these slides later, which will be made available, of course. To just talk about some of the updates we made in version 1.5. I mentioned the time extension going from water year 2015 to water year 2021. It's not as simple in some cases as a simple time extension. In some cases, some of our data sets have been expanded and updated and improved backward in time as well. Noteworthy, I think, the land use and evapotranspiration or ET data sets have been improved for the entire temporal period of our model simulation. And that's going to be a big change that GSAs will want to look at as they look at the changes in the results for their areas. And so this slide describes some of the changes that we've made to our root zone parameters or root zone modules. If we can go to the next slide, which I believe addresses some of the changes we made to our surface water representation. Here we've updated data sets based on USGS and CDEC gauging and observations. We've also been able to coordinate with some GSAs and get some better data from them locally to incorporate into our statewide models. And so some of that data that we've gotten that's led to some improvements includes better information on the diversions and just the diversion quantities and how much is, but also, diversion quantities and essentially what we might think of as the place of use or the delivery area. So maybe before one diversion would be spread out, large diversion spread out over a large area. We've been able to refine that to split it into multiple diversions that are targeted to more accurate areas that reflect water use on the ground in the real world. Next slide. Similarly, for the groundwater component of our model, we've made some improvements in where we've been able to get data from locals and including some GSAs on specified pumping. We've been able to apply that specified pumping in our model. I mentioned earlier that a lot of times we have to calculate pumping where it's unknown, but where we've gotten better data, we've tried to incorporate that into our model as well. And of course, observation data, we know that through the implementation of Sigma and the GSPs, that a lot of data has been collected. So we're refining our observation data set that we use to calibrate our model with. Next slide. What you won't see in version 1.5 yet, but that we know is going to be coming down the line in version 2.0 and beyond, is some improvements to our the structure of our model. And by the structure, in this case, I'm talking about some of our grid spacing, horizontal and vertical, the number of layers we have. We know that we need to improve enhance the resolution of our model horizontally and vertically in some cases, better align with the latest understanding of the conceptual model of the Central Valley. Much understanding has been gained through implementation of Sigma, and both from local efforts as well as our statewide efforts that Stephen and Catherine and Tad described earlier. So my team is working closely with the basing characterization team to think about the ways we can better align our model with the conceptual model of the Central Valley. And we also know that we need to have some more layers in some cases, to better simulate some things like subsidence and depletion of interconnected surface water. So those are things that we're currently evaluating and will be coming down the line. Next slide. So again, that was a very rapid fire look at our modeling work and the models we have available right now. I've linked the modeling BMP, the modeling code, IWFM, the various flavors of our applications, two CTV sims and the SVSIM model. And of course, if you have questions that pertain to modeling directly, you can reach out to us in the Sustainable Groundwater Management Office at C2VSIM Tech Support at water.ca.gov. And that does it for me. So I'll pass it on to, I believe, Paul. Yeah. Thanks, everyone.
Thanks, Craig. Hi, everybody. Paul Goslin, TWI Deputy Director for Sustainable Water Management. Greetings from Grimes. I'm down here at RD 108. And so I just wanted to join you all and, wrap up the Groundwater Awareness Week. The whole team at Sustainable Groundwater Management has put together a great program, and your participation has been really awesome. I think the sharing and other events that went on really are going to kick off, this 25-year anniversary of Groundwater Awareness Week. So again, we want to thank you all for attending today's webinar and other webinars and workshops that were held this week. We also want to highlight some of the things that are coming up in the resources and events to continue celebrating this 10th anniversary of the Sustainable Groundwater Management Act. So well permitting, observations and analysis, looking at local successes and challenges for complying with the executive orders in 22 and 23, and that was released last week. So I encourage you all to take a look at that and the recommendations that have come out on that one. Funding mechanisms, this is really top of mind for all of us. The resources that you're all going to need to do to carry through the important work that you do is challenging. So we're going to come out with a high-level resource guide with a focus on self-funding and supported by consultant subject matter experts. And so we'll be coming out with that in March. Best management practices document, and this has been one of the more challenging indicators to address. So like other guidance documents, we really felt, besides the communications with agencies, putting out either guidance documents or best management practices is very important. So subsidence best management practice is going to be developed by the fall, and it's really going to identify the steps that can be taken and should be taken by local agencies to really achieve the Sigma goals of avoiding or minimizing subsidence. Another important guidance document is the depletion of interconnected surface waters. And this is, again, another one of the important indicators that are complex. So this is going to be a series of papers giving a general overview of the technical aspects of interconnected surface water. And we'll discuss the quantification of depletions of interconnected surface water due to groundwater extractions. And we had the first paper was released in February. So we have subsequent papers coming out in the summer, and the full guidance is going to come out in the fall. So please take a look at the web page, and the document that was released last week. It's good read and good foundation for ISW. Groundwater trading white paper as a follow-up, the California Water Commission in 2022 developed a white paper on groundwater trading. And again, many basins have are either in the process or have set allocations. And some of these are very small allocations, and they're exploring opportunities to trade pumping allocations within a basin. So like, unlike any market, if it's not regulated, there could be issues and problems. So the California Water Commission came out with a white paper on that for recommendations to the department. So we're going to be working through this year to come up with our next steps on implementing those recommendations. And then, you know, the spring GSA forum's coming up on Thursday, May 23rd. So the registration link is there. So, you know, hope to see you all then. And with that, I just want to thank you all and look forward to this exciting year, the 10th anniversary of Sigma. So thank you all, and I really look forward to continue working with you all on this incredible journey on sustaining groundwater throughout